Welcome back again to the channel. On this video we're gonna discuss the following problem. So I came across this problem from the channel of Flammable Math. So it was a question from AMC. So I will just rephrase the problem. It is not exactly as the original, but basically this is the same question. So we have four circles of radius 1, and then OPQR are the centers of all these four circles. And then we are looking for, first we want to find the area of X, and then next we want to find the area of Y, and then the last one we want to find 4 times the area of Z. Okay, so let's look at this problem. So notice that since O is the center of the left circle, therefore the length of that red line is exactly 1, because the radius of the circle is 1. The same thing, this is also 1, and that's also 1. Therefore, what we know is that the red circle is an equilateral triangle of radius 1. And in particular, since it is equilateral, then the angles are all 60 degrees. Okay? Now notice we have a bunch of triangles that exactly like this. So we have that triangle. Can you figure out why it is the same triangle as the previous one? This is the radius, that's the radius, and that's also the radius, right? And then we can see that we have all of these are all equilateral triangles. See? Nice, isn't it? Okay. So now let's say we want to find the area of X. So X, this is it. X is twice of this. So X, or X over 2, is exactly that guy here. Okay. Okay. But notice that this is nothing but that area here minus the area of the equilateral triangle. Since this is equilateral, therefore the angle here is 60 degrees. Therefore the area of this region is 60 over 360 degrees times pi radius squared, but the radius is 1, so 1 squared, minus the area of this triangle. And remember that if we have an arbitrary triangle where this length is A and that is B and that is theta, the area of the triangle is half of AB sine theta. So in this case, the area of this equilateral triangle is 1/2 times 1 times 1 times sine of 60 degrees. And sine of 60 degrees is nothing but 1/2 square root of 3. Therefore we have pi over 6 minus 1/4 square root of 3. So in order to get the x, we just need to multiply by 2. Therefore x is pi third minus 1/2 square root of 3. So that is for part A. So we just computed the area of X. Now let's compute the area of Y. So Y is this shape. Okay? If you see that Y can be obtained from that shape plus that 2. Right? But one of them can fill in here. Okay? So basically Y is nothing but this thing. So this is y. So y is the area of the equilateral triangle plus the area of the circle segment of this. Okay, we have calculated this, which is 1/2 square root of 3. Okay, and we have also calculated this one, and that one is exactly this: pi over 6 minus 1/4 of square root of 3. The 2 cancels, so we have pi over 6. Okay. Now for the last problem, we are looking for the area of z. Okay, and notice z is exactly the same as y. So z is this one, right? And that's exactly y. So you can see that z is like this. Okay, so we have the triangle. Remove this segment, this circle segment, and fill it to the bottom of the triangle. So we have exactly one equilateral triangle and the circle segment. Okay, and this is z. So z is exactly y, which is pi over 6. Therefore, 4 times of z is just 4 pi over 6, which is 2 pi third. So that's all. I hope you like it. If you like it, please subscribe to the channel, and thank you, and see you again in the next video. Bye bye.